Hi, Meeting C++. This talk is on AI assistance for C++ developers, and my name is Michael Price. I'm a product manager on the Microsoft C++ team, where I focus on using the power and flexibility of cloud computing to improve C++ developer productivity and satisfaction with developer tools produced by Microsoft and GitHub. This session will discuss some fundamentals of the artificial intelligence tools that are rapidly emerging in the developer tools market and demonstrate how C++ developers might use these tools in the coming years. Finally, we'll discuss principles for responsibly developing artificial intelligence so that the tools that we build on top of these technological advancements provide benefits while reducing the potential for harm to users and the public at large. I want to start off by clarifying what we mean when we're talking about AI assistance. We'll break it down into parts and cover some artificial intelligence concepts first. Artificial intelligence can be defined as a broad set of techniques used to train computers to complete tasks that would otherwise require human intelligence, such as answering questions, generating data, and recognizing objects. What I find interesting about this definition is that to satisfy the requirements set forth, something doesn't need to exhibit what we call human intelligence, but rather emulating this idea well enough to provide some benefit is sufficient. This is an important distinction with something called artificial general intelligence. That phrase is usually associated with computers or other technology gaining sentience or a true sense of self-awareness, complete with internal motivation and the ability to take independent action. The field of artificial intelligence has been around for a long time, almost as long as what we call computer science today. Throughout the decades, different implementation strategies have been pursued and developed in the field, including expert systems, genetic algorithms, neural networks, and recently the appearance of large language models. Some of these methodologies perform better for classification systems, where an AI system is tasked with evaluating input against some known state or fitness function. And others are better suited for generative tasks, where the AI will generate some potentially complicated output based on the input. LLMs are the driving force behind the recent spate of AI assistants, so let's talk about those in a little bit more detail. Large language models, or LLMs, are models trained on large amounts of text data that can perform a wide variety of language tasks, including text summarization, generation, and categorization. We'll discuss what some of those terms mean on the next slides, but I want to emphasize that these models are created from extremely large amounts of data. Each LLM will be built from different sets of data, and the procedures for building them will vary between them, which results in potentially very different responses to the same prompts. But they generally are using the same kinds of techniques. Let's look at some of the key terms you'll want to understand to fully appreciate their complexity. The process of creating a model from a training data set is quite obviously called training. The model that is created by training is a graph data structure where the relationships between natural language components are stored. Nodes in the graph represent tokens, and relationships between them are called parameters. During the training process, the incoming data is broken down into tokens. The exact definition of what is a token and how the input gets tokenized varies between LLMs, but you can think of a token as a small enough unit of the language that you can determine relationships between them in the language. Once a model has been trained, you can use that model to generate some responses, sometimes called a completion to a prompt. Generally, the larger number of tokens and parameters a model has, the more sophisticated the response it generates from the prompts. Let's look at a very simplified diagram of how all this works. So in this diagram, we have some training data in German that roughly translates into English as, "Let each sweep his own door, and every quarter of the city shall be clean." That training data will get tokenized, and the training process will produce the model, which consists of these tokens and the complex relationships between them, the parameters. At some point later, the LLM is provided with a prompt of this other German phrase. In English, it would be something like, "How do we keep the city clean?" This also gets tokenized and then sent to the model for prediction. The model will look at the relationships in the prompt and determine what the next token is likely to be, until it determines that it is done, or it hits a practical limit. This is effectively a very sophisticated and complex version of word prediction that you likely see every day on your smartphone when you're writing a text to a friend. So, what LLMs have been created in the past few years and by what organizations? The first of what we call LLMs were created less than 6 years ago. In 2018, Google created the BERT LLM. And the next year, they also released a second LLM. 2019 also saw a relatively new player in this area, OpenAI, release GPT-2, which had generative capabilities that the two prior ones from Google did not have. Then in 2020, OpenAI released a follow-up called GPT-3, and in 2021, Google released GLAM. Then, in 2022, we started to see many more LLMs appear from many other vendors. Google produced several LLMs in 2022, and Meta also entered the market with OPT and later Galactica. Beyond those, 5 additional LLMs were released in 2022, for a total of 10 new LLMs in 1 year, twice as many as in the previous 4 years. And in 2023, this trend has only sped up. Meta introduced Llama and its successor Llama 2. OpenAI released GPT-4, which is a significant improvement over GPT-3, and Google released their iteration on the Palm LLM that had been released about a year earlier. 10 additional LLMs have also been created in the first 3 quarters of 2023, making the total for this abbreviated period 14. And as this revolution has occurred, the sophistication of these models has increased dramatically. It's common for LLMs being introduced today to have hundreds of billions of parameters and trillions of tokens. So now that we've covered LLMs, let's talk about what it means to be an assistant. Our friends in the dictionary industry say that the verb assist means to give usually supplementary support or aid to. Supplementary is a key word in this definition. An assistant isn't there to completely solve your problem. Their purpose is to supplement your own knowledge, skills, and judgment in service of accomplishing your task at hand. You, the developer, determine what sort of aid the assistant provides. This has 2 implications that I think are worth pointing out. The developer is responsible. If an AI assistant suggests a line of code to insert into a source file, it's still the developer's responsibility to ensure that the code is correct. And developers should be very critical of any information that the assistant is providing to you. By their nature, the information they will present to you likely will sound very convincing. It's the job of the developer to use their judgment to evaluate the information the assistant is presenting. A useful guideline is: think of an AI assistant as a very eager, overconfident beginner with access to an enormous library and the skills to quickly find and collate information. It does not possess reasonable or really any judgment. So let's talk about the different ways that you can be assisted by an AI assistant. How might AI assistants deliver their supplementary support? Broadly, there are 2 ways that you might interact with these assistants. The first is the conversational model. In this model, your interaction with the assistant will take the form of a series of related questions or requests. After each prompt and response, you may provide a follow-up prompt, and the assistant will have some recollection of the prior prompts and responses. Some assistants may also make helpful suggestions for follow-up prompts to help you direct the conversation in a way that you find useful. This approach is helpful for discovery and gaining an understanding of an unknown aspect of a codebase, library, or platform. Another way that AI assistants might provide their help is to focus on a particular kind of problem with a limited amount of user interaction, perhaps just triggering the assistant and accepting the suggestion. This task-focused approach will usually be tightly integrated into the developer's inner loop of code, compile, and test, and will eliminate or greatly reduce a lot of boilerplate work that developers currently do manually. Some will be active, meaning that a user will explicitly request assistance with a task, while others may be passive, with the AI assistant taking on tasks without being invoked directly to do so. With each of these approaches, the ability for the user and/or the tool to provide a properly crafted prompt is a crucial component of getting a useful response. Because of the importance of writing good prompts for these assistants, we are seeing a new software engineering discipline appear that is called prompt engineering. Prompt engineering is the practice of crafting input to LLM-powered AI assistants to obtain suitable and desirable responses. There are a handful of useful prompt engineering tips to consider as you start interacting with these tools. Set a persona. It can be surprisingly effective to indicate what sort of role the assistant should take. The description of these personas can help direct the LLM down useful paths when it is considering subsequent portions of the prompt. Provide context. By default, the LLM has no prior knowledge of anything that it wasn't already trained on. In order to get the most useful responses, you should provide enough context with which the rest of the prompt should be considered. Many tools will provide shortcuts for you to provide useful context, such as source code or other data that shows up in your editor or IDE. Specify constraints. If you know of responses that you do not want or some qualities of those undesired responses, tell the LLM that those should not be included, and it should be able to exclude those in its response. Multiple submission. LLMs are non-deterministic systems. You can provide the same prompt to the same LLM and get a variety of responses. Usually they are not terribly different, but sometimes one of the responses will be more desirable than the others. LLM limitations. LLMs and the APIs to them have limitations. For instance, LLMs can only support a fixed number of tokens in a prompt. So if your prompt is too large, you run the risk of part of it being lost, or of the request to fail entirely. Most LLM APIs also have to throttle traffic to preserve access and reduce bottlenecks and denial of service attacks. Specify output formatting. This is especially important for task-focused prompts, where the response to the prompt will be programmatically interpreted. But even in conversational applications, specifying how the response should be formatted can force the LLM to be more direct and terse, which can be valuable to the user. And then finally, threat modeling. Since these systems are complex prediction engines, if a malicious actor can inject text of their choice into a prompt, they can potentially cause information leaks or misleading responses. Everyone creating or using these new class of tools should become somewhat familiar with the risks exposed by emerging threats like these injection attacks. So with the understanding you have now of these tools, let's look at how they can be used in a C++ developer's day-to-day activities. So here we have GitHub Copilot Chat, and I want to learn a little bit more about how to use it. By typing / I can access a list of commands that will help the AI understand what it is I'd like to do here. Here I've triggered the help command to give me more information about how I can use GitHub Copilot Chat. So I have an old project that I started about a decade ago that I've been interested in picking back up. I've already updated it to do sort of modern CI and package management and build systems, but I want to keep making improvements to it. So I want to learn more about what this project is. So I'm going to ask Copilot Chat, what is it that this project does? But as you can see, Copilot doesn't really understand what this is. What this project is without actually having more context. I can ask in a different way. Maybe if I tell it about the current project, he'll understand. But GitHub Copilot kind of gets the idea, but still doesn't have enough information to really tell me what the project is. So I'm going to open up the README file and give it a little bit more context. Now this README file is about as simple as they come. It doesn't really have a lot of information in it. But even that is enough to sort of help GitHub Copilot understand what the context is. So I can ask it the same question I asked before, but now that it has this context, it can give me more information about what koans are and what they mean in the context of this project. So I want to continue learning more about the project. So I'm going to ask it what language it's currently the current project is written in, and it's going based it's deriving this based just on the name, and it understands that CXX is sometimes used instead of CPP to indicate that it's a C++ project. So then I ask, okay, well, tell me some of the koans that are in here. And again, it doesn't really have the context to really give me a list of all the koans that are in this project. But it is able to determine what sort of koans might exist in a project that is teaching C++ through koans. Now, I want to continue exploring the project, and I'm going to start in the main.cpp file where my main function is. So I'm going to tell Copilot to tell me what the main function is doing. It does a pretty good job of describing what it's doing. Now, it's a simple function, but it does a good job of indicating that there's a server involved and that it's listening on a port. And it understands that it's likely to be pulling files from certain directories in my source tree. It also understands that it starts the server and it waits for feedback, and then it'll call stop whenever the function is exiting. So I want to ask what the CXX koan server object is responsible for. It does its best job. It's answering kind of generically. And this is partly because it only knows of this because of what's in this file. It doesn't actually see the CXX koan server file. So let's go ahead and ask the question that it suggested. Now, it suggested this question, but it turns out that even though it knows that this file exists out there, it only knows it because of that include statement. It still doesn't have the context of the source file itself. And it realizes this and tells you that it would like to see more. Let's open up the implementation file, though, and see what sort of information it can give us about that. So let's take the suggested question again, the suggested prompt. And it looks like it can understand quite a bit about it. It understands that it implements an HTTP server using the C++ REST SDK. It understands that it serves up static files and that it is handling different kinds of resources. So let's ask it about what the C++ REST SDK is as well, because I happen to know, that is a Microsoft library that is deprecated, and I think I'm interested in actually updating this tool to depend on a library that's actively being maintained. So let's ask it what it knows about the C++ REST SDK. Yeah, so that's actually a really good description of it. It understands it was a codename Casablanca. It understands that it's a cross-platform library, and it understands the goal, the purpose of the library. It even understands that it handles and produces JSON data. And it also sort of understands the usage of this library within the context of my project, and that I'm using the HTTP listener object to create an HTTP server that listens for requests and responds to them. So I've identified one potential improvement replacing the C++ REST SDK, but I'd like to still get a little bit more in-depth understanding of the other parts of the product. So I'm going to take a look at a few different classes here, a few different source files here, and see if it can explain to me what it is they're doing. And when I do this, we'll see some of the limitations, some more of the limitations of these AI assistants, in that it can only process so much context because of the limitations that the API for the LLM has. So we ask it about this HTML printer source file, and it does a good job about describing what it is. But then it claims that there's not a CXX koan HTML printer class defined. So I remember whenever I first implemented this that I didn't implement this functionality as an object. I just use a collection of functions. And so I'm pretty sure about this. Let me just scroll through here and check. And yep, there's a print koan as HTML function. I'm pretty sure that's the one that implements the functionality here. So let's just let's just let GitHub Copilot in on the information that we know, and maybe it can give us a good summary as to what this function is doing. Yep, and it understands that, oh yes, right, you're correct here. So it goes and describes what the print koan as HTML function does, and that it's doing what it thought that a hypothetical class type might be doing. Let's see what information GitHub Copilot Chat can provide about this source file. Interesting. So it claims that there is no actual implementation of the get koan exercise answer, but it doesn't make a whole lot of sense because this thing wouldn't have built if that function didn't exist. And sure enough, there's the definition. This is an example of GitHub Copilot Chat not being able to grab enough surrounding context to really truly understand what's going on. So I'm just going to tell it that, hey, there is a function down here, and now that I've scrolled to it on the screen, it should give me a better answer now. Yep, and once again, with a little bit of help, GitHub Copilot Chat was able to find the thing and do a summarization of what it's doing. So let's ask it a little bit more about some of the non-C++ code sections of the project. So I'm going to ask it about the www resource folder and what all exists in there. And again, I ran into the problem of, well, it doesn't actually have access to the file system in order to actually inquire about what files are there. But it understands the pattern that www is usually is usually a directory that's used by web servers to serve up static files and such. So it does a pretty good description. It even gets some of the names of some of the source files and directories that are underneath it just by guessing. Now let's ask it a little bit about the koan files that we have. These are special files that are basically source files with some special annotations for certain sections. These get turned into HTML source files through that HTML printer source file, through the functions in that HTML printer source file. Let's see if it can tell what these source files are intended for. So I ask it, tell me what this koan is trying to teach. And there are safeguards built into GitHub Copilot Chat. It's understanding koan to mean koan in the sort of philosophical practice sense, not in the sense of this particular project. So I'm just going to modify my prompt sum to be a little bit more clear about what I'm asking. Tell me what programming principles of C++ this koan is trying to teach. Now that was just enough of a prompt to get it over the safeguards that were put in place to make sure that it doesn't answer potentially controversial questions or things that are not related to programming, because this is a programming AI assistant. So it does a good job of explaining what this particular koan is trying to teach. It's all about teaching what tokens and literals and operators are in the context of C++. So let's ask it about the static assertions koan. And this time, I'm not going to give it a lot of context in my query. I'm just going to ask it, and what about this one? And it understands all of the previous context from the conversation we've been having this whole time. And it can answer the same question about this source file and tell us what it is that it's teaching. So now what I'm doing is I am going and executing a build of this. I want to just kind of like test and make sure that the project as it exists in its current state before I start making changes is actually doing what I think it's supposed to be doing. So let's build this and debug it and see what the actual product looks like. All right, it's built. Now I'm going to start a debugging session. And because this is a web server, VS Code detects that it opened up a port on localhost, and it does an automatic port forwarding so that I can access this on my system. Now this is actually running inside a code space, and so the actual execution is happening off on a server somewhere, but this port forwarding allows me to then view it on my local system. So this is what the web page looks like whenever you go to the About Static Assertions koan. And you can see here it presents this as source code. And on the line where you are supposed to add the code that will cause this thing to be a valid statement, there's an input text block, and currently it's shaded red because this assertion is failing. So let's go ahead and see what happens if we type some stuff in. If I type in true and then tab to the next field, it will turn green, and if I go back and put false, it'll turn red again. Let's set it to true, and then let's put the right text in here for the static assert message, and it's all green. So let's go on to the next koan. And the next one is about keywords and identifiers. I can fill in the correct tokens here, and voila, everything is green. So now what I want to go do is I actually want to go do that piece of work that I identified earlier. And I want to swap out the C++ REST SDK with a different library to implement a RESTful HTTP server. So I don't know what library I want to use as a replacement, so I'm just going to ask GitHub Copilot Chat what it thinks might be good replacements for the C++ REST SDK. Oh, great. It found a handful of different libraries that I could use. I'm kind of more curious about the Poco C++ library, so I'd like for it to explain to me more about those particular set of libraries and what it offers. Yeah, that sounds like a pretty good library that I'd like to use for this. So now I need to understand, okay, now that I know which one I want to try, what do I need to actually do to do this replacement? Okay, it's given me a list of things. Now, I don't want to remove the C++ REST SDK until I have a fully functioning Poco net replacement. So I'm not going to do things in the order that it suggests here. But this gives me a good starting point at which from which I can understand what I need to do. So I'm going to ask it what I need to do in order to actually integrate the Poco libraries through my VC package manifest file. And it gives me a little snippet of code that I should be able to go and put in my VC package manifest file. Now, as it turns out, this snippet of code isn't quite right. There's some extra fields you have to add in if you want to use versioning. But I don't really need strict versioning for this project. This is just a side hobby. So I'm just going to remove all of the versioning information and just depend directly on just add POCO directly into here, and we should be good to go from VC packages point of view. Yep, and there it goes. It's off and it's downloading POCO and all the dependencies it has and building that stuff for me, so I don't have to bother myself with learning how to build POCO myself. And now I've sped this up. It takes a few minutes to do this, but for the interest of this demo, I sped that up. And now the POCO libraries are actually installed in a place where my project can take advantage of them. So now I need to go update my cmakelist.txt file. So at this point, I'm going to start using the GitHub Copilot inline completion instead of GitHub Copilot chat. So I know enough about CMake that the first thing I need to do is I need to do a find package for this POCO library. So I'm going to go ahead and find the right place in the file and do find package. And it first suggests boost, but I don't want to do boost. I'm going to type in POCO. And there we go. There's a completion that was done by GitHub Copilot. Now, I don't think I need util and foundation libraries. I'm going to remove those. And then I know that the next thing I need to do is I need to add it to my target link libraries. So I can go to that line and start typing in, and it suggests POCO.net in there. I'm going to go ahead and do a reconfigure, and that worked really quickly, which is great. And I'm going to execute a build. I'm going to make sure all the things I did for the CMake list file are actually working. The build's going along, and there we go. The build finished and everything linked. So now let's revisit the code that it actually suggested. And what I'm noticing now is that the code that it suggested earlier on is actually for a client. Let's go into our server header file. So let's just see what happens if I use the GitHub Copilot inline completions to just give me a suggestion about what it is that I should put here. And look at that. It actually gave me the header for HTTP server. I'm guessing that it probably recognized that the type of the name of the class in here was server, and maybe that I have other things in here that are in that same vein. So my guess is that's why it suggested that header file, which was right on. So let's go in and see what I need to add as a member of the server class. So I'm going to start typing POCO. Oh, yeah, wait, no, it's an uppercase P. Let's go into that namespace. Let's go into the net namespace. Okay, and let's see, it didn't actually suggest a type for me, so I'm just going to use regular IntelliSense and then give it a name. Okay, so I'm pretty sure that this object probably doesn't have a default constructor. So let's go into my server constructor and initialize it properly. So it looks like it needs to have an HTTP request handler factory pointer. Okay, I don't know what that thing is. Let's go ask GitHub Copilot chat what it is I need to do to create an HTTP server using POCO.net. Okay, here we go. It's talking about an HTTP request handler, which is right up the alley of what I was getting stuck on. So this explains that you have to have a handler type and then a factory for that type. So let's go ahead and just go over to the source file. I'm going to copy the code for the request handler, but I don't really like the name, so I'm going to give it a name that I prefer. Let's try koan server. Sorry, let's try koan request handler. Okay, let's try to use GitHub Copilot inline completions to generate the factory. Wow, look at that. It came right up and gave me pretty much exactly the right thing named with the same pattern of the thing that I renamed earlier. And yep, it looks a lot like the piece of code that the GitHub Copilot chat suggested as well. Now let's go back to the initialization of the HTTP server object and give it a new request handler factory. And then if I look at the IntelliSense hint that it's giving me, it says I can actually just give it a port number. I don't have to create one of these server socket objects. So let's just give it a port. We'll say 8082, and there we go. Okay, let's build that and make sure that that compiles. Oh, okay, it didn't compile. Why did it not compile? It's complaining about base class has incomplete type for the base class of my request handler. What this probably means is maybe I'm missing the header file for this. So let's go back up to the header files in our server CPP file and see if Copilot can just tell me the right ones I need to include here. Okay, I'll include HTTP server. Okay, request handler factory. That sounds like a good one. I know I used a type from there in part of the code I added. And there's our request handler header file that hopefully should define the base class that we're using. And look at that. The build successfully compiled and linked. Now I know from previous experience that you usually have to start and stop these things, and I even have a start and a stop method on my server object. So let's go in here and call the start member function on our server in the right place, and we'll do likewise for the stop function. Okay, let's build again. Okay, built and linked. Okay, let's actually debug this and see what happens. Okay, it looks like it's successfully bound to port 8082. Okay, great. I'm not actually going to go check this with a web browser because I know that my request handler basically did nothing. So let's go implement that next. Let's ask the inline GitHub Copilot chat what the simple implementation of the handle request function. Generating a simple hello world response is fine. Now you access this in VS Code with Control-I to bring up the inline chat interface. This is pretty reasonable. I'm going to accept this and it's going to insert it in here. And I happen to know that I need to set the status as well. So I'll add that in. Oh no, it failed. Why did it fail? Of course. It actually didn't give me a function body. It gave me a full function definition, including the signature. I don't need that stuff, so I'm just going to remove it. All right, let's try again. It still failed. This time, a member access into incomplete type HTTP server response. Well, we know what this was last time. This was a missing header file. Okay, well, let's go see if GitHub Copilot chat can tell us what a header file should be added to fix the incomplete class error. Well, it's not terribly helpful. Let's see if we do better with GitHub Copilot line completions. There we go. We had almost typed the full thing, but it eventually got there. Ah, yes, and of course, it's not HTTP response.h that we need. It's HTTP server response.h that we need. All right, it looks like the build finished. Now that we're actually handling the request and providing a response, let's do a debug session of this and see if it's working. All right, we're over here in our browser. We've connected to that locally forwarded port, and sure enough, the response was "Hello World." This is an indication that our HTTP server is actually up and running. So the next steps I'll take are to migrate the REST interface currently implemented in the C++ REST SDK and implement that in my PocoNet HTTP server. But in the interest of time, we won't be able to do that in today's talk. I'll just have to save it for later, but now I have a running HTTP server, which is a good start in completing my removal of the C++ REST SDK in favor of an actively maintained HTTP server library. So let's talk about the framework that Microsoft has set out to make sure that artificial intelligence-powered products are made responsibly. Microsoft has published the Microsoft Responsible AI Standard that has 6 core principles. Beyond the principles that I'll describe, there are specific goals with detailed requirements that map to these principles in the published Responsible AI Standards document. You can read in more detail about this standard at the link at the bottom of the slide. www.microsoft.com/ai/responsible-ai. We'll start by looking at the principle of fairness. How might an AI system allocate opportunities, resources, or information in ways that are fair to the humans who use it? This is important because LLMs and other AIs that use a training data set will inevitably display any biases that are inherent to the training data. But the normal remedies that might be used to address biases by humans, such as a conversation with a manager or coworker, may not be applicable to an AI assistant. Therefore, it's important to develop ways to balance, counter, or eliminate biases that may be exhibited by AI systems. A good example where you want to make sure that AI was fair would be an assistant that identifies job applications to forward to a hiring manager. If a system was trained to look at the applications of successful and unsuccessful applicants without guardrails, it would be likely to exhibit the same kinds of bias that had been present in whatever system existed before. For reliability and safety, designers should consider how might the system function well for people across different use conditions and contexts, including ones it was not originally intended for. It is a fairly standard practice for computer science students to learn some about the need to make sure that software functions in safe ways that will not fail in catastrophic ways and potentially cause serious harm. These are not hypothetical concerns, as incidents such as the radiation poisoning and deaths caused by the Therac-25 radiation therapy system in the mid-1980s. For example, an AI-powered computer vision library that detects pedestrians crossing into the path of an automated vehicle needs to be designed to take into consideration a potentially unbounded set of environmental constraints that may not be represented in its training data. Temperature, low light conditions, worn-out roadways, and unpredictable human behavior. Failures to build in reliability and safety features to the system could result in catastrophic consequences. Designers of AI systems should ask how might the system be designed to support privacy and security. As sensors of various kinds become ubiquitous and as people and systems around the world become more connected, threats to the privacy and security of individuals will continue to rise. 40 years ago, it would have been almost inconceivable that nation-state actors could hijack the equipment of someone in another nation to be used in further attacks or to steal private information about that person. These and other threats to the rights of individuals should be safeguarded by building AI systems that take these concerns into serious consideration. An AI assistant that identifies affordable housing that is likely to be attractive to single-parent families could be a useful tool for many families. But it also provides the potential for an abusive spouse to violate the privacy and security of someone who escaped that abusive relationship. How might the system be designed to be inclusive of people of all abilities? Developers of products will bake assumptions about users into their products, often based on their own experiences. But this can result in products that only work for a select group of people, leaving other populations in a disadvantaged position and removing them from the market for those products. Making an AI assistant support a wider range of users by accommodating their differences where necessary can result in happier users across the board. Consider an AI assistant that summarizes the conversation between a patient and medical professional for the purposes of medical record keeping. If the patient speaks a different language than the medical professional, or perhaps speaks with a pronounced accent, an AI assistant that wasn't designed to be inclusive might incorrectly summarize the conversation, which could have a lasting impact on the user's health and the medical professional's ability to provide their best health care. How might people misunderstand, misuse, or incorrectly estimate the capabilities of a system? It's important for users of AI systems to understand the limitations of those systems, and that means they should be designed with transparency in mind. Any response from an AI assistant should be clearly indicated so that users can make the best informed judgment about the helpfulness of the assistance. Take the case of an AI-powered application that is used by parents to monitor their newborn's sleep patterns. If the parents do not fully understand the limitations or intended use of the system, they may trust the application to also keep track of the child's temperature or other health metrics, when it was never intended to do so. This could result in a delay in seeking medical care due to the misunderstanding of the application. And finally, how can we create oversight so that humans can be accountable and in control when it comes to the artificial intelligence systems? Remember, I said that developers are ultimately responsible for accepting or rejecting the recommendations or advice of their AI assistants. AI, at least none that yet exist, do not possess judgment. That is something that humans have near exclusive domain over, discounting possibly a few other known species. So imagine installing an AI-powered application in your home that predicts grocery needs for your household and places orders with the delivery service when it notices that some item is about to run out. Now imagine you throw a huge party at the end of the year and purchase several gallons of eggnog. A week or so after the party, a huge order of eggnog shows up at your door without you expecting it. It is doubtful that you really wanted a 6-month supply of eggnog, but the AI application was just basing things on your prior behavior. And without the accountability of a human being in control, you'll be sipping on that seasonal treat well into March. I want to thank all of you for watching my talk on AI assistants for C++ developers. The mission of the Microsoft C++ team is to empower every C++ developer and their team to achieve more. We hope that you try out our AI products like GitHub Copilot and GitHub Copilot Chat, and that they indeed help you achieve more in your role as a C++ developer. Enjoy the rest of the conference, and if you have any questions about our tools, including AI assistants, please contact us at visualcpp@microsoft.com or on the platform formerly known as Twitter at visualc.